for my research paper is early warning detection of cybercrimes through a deep learning approach. I choose this topic because recently few of my friends had credit card details stolen by hackers and now they are having to pay that loss. This not only affects a student, it can also affect a banking sector like JP Morgan in 2014 had to go through a data where the information about small-scale businesses and industries were collected. To mitigate these incidents and raise awareness, I have selected this field of cybersecurity. My main objective is to create a system that helps in early detection, which can be done with the help of deep learning. Well, while I'm explaining, I'm going to use the example of phishing because recently Google and Facebook had to go through a phishing attack. How? Google and Facebook use a common vendor called Quanta. The attacker had sent messages to the employee saying that he is an employee from Quanta. Obviously, the employee thought that this information is important to the company and opened or visited that page. There, the attacker has collected all the information about Google and created his own database. This kind of technique needs to be, or this kind of attack needs to be identified early in the stage. So that's why I'm using digital forensics. So here, what I'm going to do is that rather than other technologies which identifies the phishing or later in the process, I'm going to identify or see the data and say, hey, this looks like there is something fishy in this one. So I'm going to start collecting the evidence right from there. Once the evidence is preserved, I'm going to start doing my analysis parallelly. Now, once the analysis is done, able to say, hey, this is where I could see the attacker attacking our site, and here is what he's doing and how he's entering our servers. I can report this to my higher authorities. Well, you might ask where I'm using deep learning in this process. Well, right after the identification, I'm going to do the collection and preservation. After that, for the analysis, I'm going to use deep learning for my interpretation and the results reported to the higher authorities. You might say this is a theory. Well, it is actually proven when Google, IBM, Microsoft used this deep learning model and were able to detect different types of phishing or uh, hardware incidents with the accuracy of 95 to 99.9%. Well, the only disadvantage in this model is that this data might be biased. As you can see, Google is able to detect phishing because Google is facing phishing issues a lot. And IBM is able to detect malware because IBM has a data of malware. So it can be biased. Apart from that, what we can do with this model is that right now the phishing detection takes around 13 minutes to detect whether this instance is a phishing or not. So to eradicate or to help us get a better computation performance, we can improve the model much better. Apart from that, we can also use deep learning technologies to increase the system efficiency. Now, coming to means that yes, forensics is the solution for tomorrow's problems. But at the same time, you can see how we are able to do early detection and how effectively it has said that this incident has been there, phishing incident is going on in the system company, and also this is applicable for the real time when Google and other companies have used this method. Lastly, this is efficient for the resources that we have because we are not adding new resources, but we are using the resources that are already present to us. Thank you.
Hello everyone, I'm Shireen Farha. Imagine detecting a disease before it becomes dangerous, which can even lead to irreversible blindness. That is exactly what my research is on. Prediction of diabetic retinopathy using machine learning. We'll now dive into what is diabetic retinopathy, why is it so important to predict it early, and how we can change the lives of those who are suffering from diabetic retinopathy by predicting the presence of it using machine learning. Diabetic retinopathy is a disease that occurs when the retina's blood vessels are damaged or gets blocked due to high sugar levels and results in optic displacement within the eye. As you can see, the above image is of a healthy eye, and the below image is an eye of a diseased person, which has hard exudates, cotton wool spots, new blood vessels grown, and you can also notice the absence of or the displacement of optic nerve in the image. Every year, millions risk their eyesight to diabetic retinopathy. Hence, it is important to detect it early in order to recover the eyesight. The objective of my study is to extract significant features from the input retinal images and explore different machine learning and deep learning models to develop an accurate system which can predict the presence of diabetic retinopathy and classify whether a person has low risk or high risk of being diagnosed with diabetic retinopathy. I finally aim to compare the model performances that were employed for prediction process. The detection process is very simple as shown in the image on the screen, where we firstly gather the patient's fundus images, which are nothing but the retinal images of an inside eye, which acts as an input data. Once we have gathered the data, it goes through what we call image pre-processing, where we clean the image and make sure it is ready for the analysis. The cleaned up images are now sent to the machine learning algorithms, which can predict or identify the presence of diabetic retinopathy. Instead of algorithms, we have a server term here, so bear with that. And after that, we can classify whether a person or he or she is being positive with diabetic retinopathy or negative with diabetic retinopathy. And here is a visual of how we have trained our machine learning model. We started with a dataset containing eye images with some healthy images and few or many affected images to help our system understand and tell the difference between a healthy and a diagnosed person. We then do XRT data analysis, that is EDA, to identify significant features, followed by image pre-processing, which I discussed is to enhance the image quality. We then split the data into training and testing sets. Upon the training set, we employ the machine learning algorithms like random forest, SVM, KNN to classify a person is at high risk or low risk of being diagnosed with diabetic retinopathy. The testing data is used after model is being trained for validation purposes. Here are our obtained results, where we can see random forest and gradient boost showed best results amongst all other models that were used. The random forest has high accuracy while gradient boosting had good accuracy and F1 score. Coming to the summary, machine learning models can identify the presence of diabetic retinopathy early with no human biases. Early detection can reduce global blindness due to diabetics and can help in timely and effective treatment. Performance of the models can be further improved with more diverse data and better feature extraction techniques. Future research can employ advanced algorithms and deep learning architectures or techniques like CNN. Here are the references that I looked upon for my research work. Thank you so much for listening.
Hi everyone, my name is Zerabha and today I'm going to present a video presentation on the topic, that is choosing the right API technology. We are going to cover this presentation for my CMP 285 class. Now, before going to explore the world of API technologies and discuss how to choose the right one for your project, we must know that as development continues to evolve, building efficient and scalable APIs has become crucial for modern applications. with several technologies available such as DRPC, gRPC, GraphQL, and REST API. Selecting the appropriate one can significantly impact the performance, flexibility, and maintainability of your application. Now, before delving into the specifics of each technology, it's important to consider several key factors that should guide our decision-making process. These factors include performance requirements, data complexity and structure, client requirements, development team skill set and experience, ecosystem and end-to-end support, and a type of safety and developer experience. Evaluating these factors will help us determine which API technology best suits our project needs. So now, let's discuss when to use each API technology. REST, or representational state transfer API, is ideal for simple CRUD operations and well-defined resource-based architectures. Whereas GraphQL, on the other hand, is perfect for fetching complex and nested data structures with a single request, avoiding overfetching or underfetching of the data. gRPC, or Google's remote procedure call framework, is best suited for high-performance, low-latency communication in microservices architectures, especially when handling streaming data. Lastly, TRPC, a TypeScript-first framework, is great for TypeScript-based projects that prioritize type safety and developer experiences. While each technology has its strengths and weakness, we are not limited to choosing only one. We can combine these technologies to leverage the best of both worlds. For example, we can use GraphQL as a layer on top of a RESTful API to provide more flexibility in data fetching. Similarly, we can also integrate gRPC for communication between microservices by exposing a GraphQL API to clients. This approach will allow us to tailor our solution to meet the specific needs. So now, how can we ensure the success of our API development efforts? To achieve this, it's essential to follow the best practices and consider the various factors which are: we must implement a proper security measures such as authentication and authorization to protect our API from vulnerabilities. We should use caching technologies to improve performance and reduce server load. We should establish a versioning strategy to maintain API changes and ensure backward compatibility. Maintain a clear and up-to-date documentation for our API to facilitate adaptation and ease of use for the future developers. We should also identify and address the performance bottlenecks to optimize our API performance. Consider the learning curve and available tooling for each technology, as these factors can greatly impact the productivity and the maintenance efforts. Lastly, to conclude all the points that we have discussed so far, we can say that selecting the right API technology is crucial for building efficient, scalable, and maintainable applications. By considering key factors such as performance requirements, data complexity, client needs, development team skill set, and the ecosystem support, we can make an informed decision that aligns with our project's objectives. Remember, these technologies are not mutually exclusive, and we can combine them based on our needs. Ultimately, experimentation and continuous learning are the key to staying ahead in the rapidly evolving landscape of web development and API technologies. Thank you, and I hope you liked the presentation.
Hi everyone, I'm Sundaja Ravi. I'm going to do a presentation on MLAS. MLAS is nothing but machine learning in autonomous system. So here we'll be seeing about the principal component analysis used in autonomous systems. So generally, what does a PCA do? So have you ever wondered why most of the movies are 2D even though the subjects are 3D? So usually this is because of the third dimension that doesn't usually add much to the story. So the camera will take the 3D information and flatten it to 2D without too much of the information. So PCA does the same thing but with the data sets. It takes a data set with lot of dimension and flattens it to 2D or 3D so that we can look and make more sense of the data. So here you can see the movie, John Wick movie versus the Avatar. So we know that these are the 3D movies, but then we get movies in 2D pictures. So this is the same in real-time analysis of PCA. So for example, here I have taken the iris dataset, and the dataset includes 3 iris species with 50 observations for each species and no null values, and there are 4 features. So the 4 independent variables that are used from the iris dataset are sepal length, sepal width, petal length, and petal width. So all these variables are in centimeters. And the one dependent variable here is the class. And this is the data that is. So the coding starts from here. So here I have imported the libraries, NumPy, Pandas, and Matplotlib, and the scikit-learn. And for standardizing, we use a standard scaler, and for logistic regression, and then we use the training model and the test model, and also we import the PCA. And here in line number 17, we read the CSV data file, which has the iris dataset, and then we print the first 5 rows of the data frame, and using irisdata.head will do the same. Then we do the class replacing, and the above line will replace the strings with numerical values for EC processing. Then we create a new data frame by dropping the column class from the iris dataset. And then we create a new data frame for column class. And then here we do the standard scaler where we take the standard deviation and then we fit the transform with the scaled X values. Then here we randomly shuffle the scaled X value and split the 80% into training subset and 20% into testing subset, and the random subset is 0 so that we can make some training and testing subset across different execution. Here in the above line where model is equal to logistic regression, we use one of the most used supervised learning classification algorithm, and the model we fit the testing model to the training subset. The accuracy here, the above line finds the accuracy by comparing the predicted value with the actual value. And then we print the same. So next we set the number of PCA components as 3 and fit the transform according to the scale PCA values. Randomly we shuffle the scale X new values and split 80% into training subset and 20% into testing subset. And the random state is 0, so we can get the same training and testing subset across different executions. And in logistic regression, we take the solver as LBFCS and the multi-class as OVR. And then we fit the model to the training subset and predict the class for the testing subset. So again, we calculate the accuracy by comparing the predicted data with the actual label. And then we plot the first principal component, second principal component, and then see the graph. So here it's in 3D dimension, and we can see 3 clusters, and the accuracy for PCA after taking the number of components as 3 was 0.9, which is 90%. And when number of components is 2, like when we display the same with the components 2, so we get accuracy as 0.83. So here the accuracy has dropped because we can see at few places at the green and the yellow clusters has overlapped in few places, and that is why the accuracy has dropped from 90% to 83%. So here now we modify the code where we take PCA, the number of components as 1, and then we scale the PCA values using the fit transformation function and randomly shuffle the scale x new value and split 80% into training subset and 20% into testing subset. And the random state is 0 so that we can get same training and testing subset across different executions. And again, we perform the logistic regression here, taking the solver and the multi-class thing. And then we fit the model to the training subset. And then we'll do a prediction of the class for the testing subset. And the above line will again calculate the accuracy by comparing the predicted data with the actual data. And we again plot the same graph and we see. So here we can see that before doing PCA, keeping number of components as 1, we can see that there are 3 clusters and the accuracy is also 90%. So, so we can see that principal component analysis is very useful in segregating the data set where the important data sets can be taken and the others can be dropped. So this is one of the most important concept in machine learning. Thank you.